right, we are going to start the section about complex numbers. When we deal with complex numbers, it involves an imaginary unit, and that imaginary unit is in the symbol I. And what I stands for is when you have a negative number underneath the square root sign, because you know that you cannot have a negative square root. There are no two numbers that will equal a positive that will be a negative and a positive, or that will equal a negative number. So for instance, what I'm trying to say is 4 times 4 will never equal a negative 16, and negative 4 times negative 4 will also never equal a negative 16. They will always be positive. So when you have a negative number underneath the square root, there's no way to find it, and that's where the imaginary unit comes into play. So whenever you have a negative under here, it will have to be considered an I, and that is only for negative 1. Now I squared is equal to negative 1, and of course if we took this rule up here and we squared this, remember the square root and the squared cancel, and you're left with negative 1, which is where they come up with this. Now, for instance, when you come across your problems in your book, you will have negative numbers underneath the square root sign. And so we're going to follow the square root of a negative number rule that says if r is a positive real number, then you have the square root of a negative number under here, which is negative r in this case. All you're going to do is pull out an I, which will take care of the negative part, and leave this number inside the square root. So for example, I have down here the square root of negative 5. So we would just pull out an I, it would no longer be under the square root sign, and the 5 would remain positive, which would stay under the square root, and this is how we would write our answer. Very simple thing to do. And that's going to help us when we go through and solve equations like we were doing in the previous section. So here we have solve 3x squared plus 10 equals negative 26. We're going to first, just like always, subtract the 10. We want to isolate everything away from our x. So we now have 3x squared equals negative 36. Okay, we want to get rid of the 3, so we're going to divide both sides by 3. And negative 36 divided by 3 is negative 12. And now we need to take care of the squared. So we're going to square root both sides. And when we square root something that is squared, they cancel. Finally, we have x isolated all by itself. And now we have a square root of a negative number. And you cannot leave your answer like that. That is why we learned the imaginary unit rules. So we're going to pull out the I and leave the 12, which will now be positive, inside the square root sign. And remember, whenever you take the square root of something and we're solving, you do need your plus minus in there. So here was our answer. Plus minus I square root of 12. Now we can also graph complex numbers, and complex numbers will always be written in the form of a plus bi, where a will be a number and b will be a number. And just like our regular coordinate system, we have an x and y axis, but instead of having a number for x-axis, this is going to be our imaginary number axis. So when we look at the a, this is kind of like the x. We're going to go over so many, and then we're going to go up or down however many i's there are, which would be your b. So up or down on the y-axis. And I think I said the x-axis right here would be the I, or imaginary axis, and I meant to say this is the y, This is the x, like normal. So I'm going to give you a practice problem here, and here is our complex number that we want to graph. And like always, we're going to start at the origin, which is 0, 0. And you're going to move 2 units to the right because 2 is positive. So just like a regular x coordinate, you'd move 2 to the right. And then you're going to move 3 units down because this 3 is negative. This is the imaginary unit axis. We'll treat it like our y. So down 3. And we want to label this a plus bi, which would be 2 minus 3i. There's the point. Very easy thing to do. So here are some more practice problems that we can do. We have -3 for our a, which is our x. So -3, we're actually going to go this way. And then we're going to go up to I, so up 2. And then label it 3 plus 2i. And there's the point. Now over here, we just have bi. Well, if we wanted to put it in the form a plus bi, we can do that. The a is just 0, so 0 plus 4i. If our x is 0, that means we're not going to go anywhere right or left. So we're just going to have to go up 4i. So 1, 2, 3, 4. And there's the point 4i. And you don't have to write the 0 plus 4i, but if it makes you feel comfortable to do so, you can. All right, now we're going to write expressions, and we're going to leave our answer as a complex number in the form a plus bi. And that is what standard form is, a plus bi. So we have for letter A over here, we have 2 expressions here, and it says to add them. Okay, so when we add things, we're just going to add the like terms, just like we do with normal numbers or x's and y's. So if we have 4 plus 3, that'll give us 7. And now we do the imaginary numbers. So we have -1, and if you want to fill it in so you can see it, that'll help. So -1 plus 2 will give us 1i. You can also just write this 7 plus I. So now we have the form a plus bi. We just simplified it. Over here, we're subtracting in letter B. So we have 7 minus 1. So 7 minus 1 is 6. So there's the first part. And now we have -5i minus a -5i. Don't forget to keep your negative here and along with the negative there. So 2 negatives by each other make it a positive, and this actually cancels out to form 0i, which we do not have to write, but if it makes you feel comfortable to write it, you can. So 6 would be the answer in letter B. Okay, we're also going to write complex numbers in standard form, which is, again, a plus bi, but this time we're going to be multiplying. Okay, so we have an expression with a variable on the outside. We're going to use the distributive property, just like we would with x's and y's. So 5 times -2 is -10, and you need to throw the I on the end. And we're going to take 5i, and we're going to multiply it by a positive I. So that would be a positive 5i squared. Okay, now, most of you would think that this is done, but this is not in the form a plus bi. This has an I squared in it. So we need to use the rule, and I think it was the first slide that I gave you in this section. And it said I squared equals -1. So we're going to change that I squared to equal -1. And now we just have to multiply. 5 times -1 is -5. So right now we have our A and our BI. It's just flip-flopped around. So we're going to put the negative 5 first and the negative 10i second. Now we have the form A plus BI. And there's our simplified answer. And it is in standard form. Okay, over here on the second example, we have two expressions. So you can do the box method or you can do the FOIL. I'm going to do the FOIL method in this one. It really doesn't matter which one you choose. So we're going to take 7 and we're going to multiply it by negative 1, which is negative 7. And now we're going to take 7 times 2i. So that's a positive 14i. And now we're going to take negative 4i times negative 1, which is a positive, because there's two negatives, so positive 4i. And we're going to take negative 4i and times it by positive 2i. So negative 4 times 2 is negative 8, and I times I is I squared. Now that we have it all multiplied out, we need to simplify this. So we have negative 7 out here. Really can't combine that with anything yet. We have 14i plus 4i. So really we have 18 i's. And I want to transform this I squared because we all know that I squared equals negative 1. We've got to use those rules. So instead of writing I squared, I'll write a negative 1. And now I'm going to multiply negative 1 times negative 8, negative 1 times negative 8, which will give us a positive 8. And now I just have negative 7 plus 8. And that's going to give us a 1. And we want to double check, is it in the form A plus BI? Yes, it is. Here is our answer. Okay, now we're going to do the same thing, but we have a quotient, which is a division problem. And whenever you have an expression underneath of this the quotient symbol, you need to rationalize it. And how do we rationalize something that is an expression? We're going to take the opposite. So we're going to take 1 plus 2i. And we have to multiply it on the bottom, and we also have to do it to the top. Okay, so we have two expressions being multiplied down here and 2 being multiplied up here. Now, some of you may have not gotten to how to rationalize in Algebra 1. And so if that's the case, I suggest you come see me during class to get some practice problems on how to do that. Otherwise, when you do this, you might be a little lost. So now we have two multiplication problems to do. We have one on the top and one on the bottom. And I'm going to use the FOIL method again. So we have 5. Actually, I'm going to do green so it doesn't get too confusing here. We have 5 times 1. So we have 5 over here. And now we have 5 times 2i, which is 10i. Oops. Sorry about that. And we have 3i times 1, which is 3i. And we have 3i times 2i. So 3 times 2 is 6. And I times I squared. Now, you can go ahead and simplify the top and then start on the bottom, or you can do the bottom now and then simplify in the end. It doesn't matter. Let's go ahead and just simplify the top while we're here doing it. Okay, so right now I have 5, and I don't have any other like terms to go with it. But I do notice I have 10i and 3i. So really I have 5 plus 13i. And I notice I have an I squared. So instead of writing the I squared, I'm going to write a negative 1, because that is what I squared equals. So now I do have a number over here. So I have 5 plus 13i 6 times negative 1, which is negative 6. And 5 minus 6 is negative 1 plus 13i. So here is the top part. Okay, so I'm going to go down here, I guess. Actually, I'll go right below it. There's our top. Now we need to work on the bottom. So same thing. We're going to use the FOIL method. We have 1 times 1. And we have 1 times 2i. And we have negative 2i times 1. And we have negative 2i times 2i. So we have a negative 4i squared. And some of you, if you notice, this is the factor rule where we had plus minus. So if you can remember that a squared minus b squared will always be equal a minus b, a plus b. You could have eliminated having to do the FOIL method here and just wrote a, which is squared, so 1 squared would be 1, and b, which is 2, square it, and then the I would be 4i squared. So see how plus 2i and negative 2i cancel? That's what I'm talking about. You could have eliminated doing that by just looking at the rule. But we don't always remember every single rule in math, and that's okay. So as long as you can remember the FOIL method, you can still get to this part regardless of the shortcuts. All right, now we need to simplify this even more. So we have 1 plus, oops, sorry, should be 1 minus, and I squared equals a negative 1. And so now we have 1 plus 4, because negative 4 times negative 1 is positive, and that will equal a 5. So here's our bottom number. And the reason we do this rationalizing is because we don't want something squared or a square root on the bottom of a quotient. We don't want to leave it that way. We always want a solid number like here. And by doing this, will get us that solid number. So here is the answer for this problem. And this is a more complicated problem. You will have to learn how to do it. All right, last thing, if I ever ask you to take the absolute value of a complex number, so here we've added, subtracted, multiplied, and divided all these complex numbers. Now we're going to do the absolute value of one. And there's a very simple rule to follow, so this would be very good to write in your notes. The absolute value signs are going to go away, and you're going to put a square root. You're going to take your a and square it, and you're going to take your b and square it. You will not have an I under here at all. And then you just simplify it. So for example, down here, if I ask you to take the absolute value of 3 plus 4i, you're going to take away the absolute value signs and put a square root. You're going to take your a and square it. Add your b and square it. So as you can tell, 3 squared is 9, and 4 squared is 16. And what is 9 plus 16? It's the square root of 25, which will simplify to 5. And there's the answer. So, again, absolute value. Always follow this rule right here. And this will be on your test. So please write this in your notes and include the examples so that you see one done. This is fairly easy. You'll have some practice ones in your book to work with.